If you build a bridge across the Pearl River estuary, you can connect Guangzhou and Dongguan, activating economic development throughout the Pearl River Delta. Traditional girder bridges require dense piers within shipping channels, which would obstruct the passage of massive vessels. So with ingenuity, you adopt a suspension bridge design in areas with heavy traffic. You erect gigantic gate-shaped towers on both banks and suspend the bridge deck using main cables and hangers, transferring the load through the suspension cables to the towers. Yet uneven forces acting on the towers could cause them to bend inward. To solve this, you construct gravity-type anchorages on the eastern and western shores. Using the immense self-weight of the anchor blocks, you counterbalance the tensile forces of the main cables, thus forming a stable anchoring system. To prevent tower settlement caused by the Pearl River's soft soil conditions, you drive pile foundations deep into the ground until they reach bedrock, and pour reinforced concrete pile caps to create a solid underwater foundation, capable of safely bearing the enormous loads of the bridge towers. However, frequent typhoon strikes pose the risk of vortex-induced vibration on the bridge deck, which in severe cases could even lead to structural collapse. Of course, this challenge does not defeat your ingenuity. You design the steel box girder of the bridge deck with a streamlined cross-section, altering airflow patterns to reduce violent oscillations. You also add central wind vents and guide channels, effectively improving airflow paths around the deck and enhancing aerodynamic stability. And so, congratulations, you have built the Humen bridge.